So the worksheet that says arcs and central angles. If we look at it, number 1 is going to give you a circle. And I guess one of the things that we need to point out is, let me just draw this in here first. Not quite at the center, but they give you, in the diagram, they give you a figure that looks something like the following. The center is Q. So it says, name the arc made by the given angle, and the angle that they are providing you with is FQE. So if we have angle FQE, they want to know what is the arc that is formed by that angle. How would you name this arc that is formed by that angle? It's going to be just FE. You could say EF, the order does not make a difference, and you put the little arc symbol above it. Now, when you are working with an arc, there's actually 2 different types of arcs that we have. One of them is called a major arc, and the other one is called a minor arc. I'm trying to record this so that we have all of this for those that are gone. What we have is we have a major arc and a minor arc. This is actually the arc that they are looking for this particular answer. The major arc and the minor arc is like when you talk about an acute angle versus an obtuse angle. It's the only difference. One's bigger than the other. So this arc right here of FE, that's known as a minor arc because it's fairly small. If we wanted to make reference to another arc, here's the other arc that we have. And the problem is what if I call that FE? Then what happens? We can't have the same name to represent 2 different arcs. So what we have is, this is what is known as a major arc. And in a major arc, you have to use one other letter. So if I wanted to name the purple arc, I would call it FDE or EDF with the arc symbol above it. And you know that you have to go through, you have to go from F to E, but through the point D. So that's how it becomes a major arc. But that's not what we want in this case. In this case, what they are looking for is that FE. So if you had to do number 2, what would number 2 have for an answer? They want to know what is the arc formed by angle 1. And they have an H here, they have an I here, you have a point J over here, and then here's angle 1. So what is the arc that is made by angle 1? That arc would be HI. And make sure, just like with a line segment, or a ray, you put the symbol above it, and HI is your answer. Now, IH would work too, you just need those 2 endpoints. It's a minor arc, so you don't need to put J. HJI would be if you were talking about the other arc. So number 2 says name the central angle of the given arc, or number 3, not number 2. Name the central angle of the given arc. What do you know about a central angle? What's the difference between a central angle and an inscribed angle? Do you remember the difference between them? Because you've talked about them before. We have a central angle and an inscribed angle. What's the difference? The central means that your vertex is in the center of the circle. An inscribed angle means that your vertex is on the circumference of the circle. So this one just says name the central angle of the given arc of the given arc, and they tell you arc ML. Better put the symbol there. Arc ML. So arc ML is right here. What is that central angle? Angle 1. That's what's given to you. They have a 1 right there in that angle. So if you look at number 2, oh, number 4, I'm terrible with that. The second one in that category, that section. So number 4 gives you another circle, and they have an arc here. They put Q here, and they put a K over here, they put an L here, and they put an M. And they give you arc ML again, which that's a minor arc. MKL would be the larger arc, and you would be talking about a reflex angle, one that's greater than an obtuse angle is greater than 180. But they want arc ML, not MKL. So there's your arc, and they want to name the central angle based off of that. What is that central angle? Angle Q. Angle Q actually has 2 angles at Q. You have this angle here, which is an acute angle, and you have this reflex angle there. So since there's 2 angles at Q, we just can't call it Q. We better call it MQL. We better use the 3-letter naming system to name that. Just be careful of that. College professor might be picky on that because technically there are 2, even though you don't view that reflex angle. Are we okay with those 2? You'd probably be able to get these on your own. Number 5 through 8. If an angle is given, name the arc it makes. If an arc is given, name the central angle. Okay, I think you can do those 4. So I'll give you a couple minutes to do those 4. Okay, so what did you get for 5? Angle RQS, also known as SQR. Number 6, what did you get? Arc, ACB. So they give you the angle, so you want the arc, and this is one where, is that a major or a minor arc? Major arc. So we have to use a BC. Clarification of that, I don't know how many of you were okay with that, because here's arc 1, and you still have 2 lines over here. Whoops, that actually angles up, but you got a 2 and a 3 here, and they want the major arc for angle 1. So here's angle 1. This would be the minor arc. The major arc is here, so you have to use those 3 points. All right, what about number 7? What's your answer? Arc KL. 8. Angle SQT. I'm good with those. Okay, the next thing. If we look at number 9, find the measure of the arc or central angle indicated. Assume the lines which appear to be diameters are actually diameters. So you look at this one, that's at the center of the circle, even though it may not look like that. I know when I step away sometimes and I look from up close, far away, it may not be that way. But if I look at number 1, we have this arc right here that is 155 degrees. You have another arc down here that's 120 degrees, and they want to know the angle with the question mark in it, which is a central angle. It measures the same as the intercepted arc. So number 9 should be a 120-degree angle. If you look at number 10, same thing with number 10. You have a central angle that's 120 degrees. So the arc it intercepts would also be 123 degrees. Now, if you remember back in Algebra 2, we found the length of an arc. Do you remember how to find the length of the arc? Yep, degree over 360. It's like finding a sector of a circle, but a sector of a circle, we took the area times the fractional part, which we dealt with the degrees over 360. The length of the arc, if you knew the radius was maybe 10, then it would be 2 pi r times the angle over 360. So if I wanted to know the length of it, the length of the arc, then you would take 2 times pi times 10 times 123 degrees over 360 degrees. But right now, all they're asking you for is just that degree measure. I just wanted to reinforce that you do know how to find that length. Okay, if you could work through 11 through 14 for me, please. So as we look at it, what is the measure of arc CFD? What did you get? Yes, 306 degrees. So CFD means there's F. So they want the arc CFD. So they are talking about the major arc that goes around. How did you go about finding it? I don't know. Did anybody figure out what? Curious to how you found it. Did you figure out what that angle measure was first? No? How did you go about finding it? You did half is 180, so you found out what this angle measure was, which is 55. No, 45. So you found out that you have a straight line right here, so this is going to be 45 degrees, and vertical angles are equal, so this is 45, and then you added those together. Okay. I looked at it like this. I looked at my vertical angle as that right there. So if this is 135 right here, then this is 135. Would you agree with that? What's 135 minus 81? Is anybody finding it? 54 degrees. So then what I did is I looked at it. I'm just going to get rid of some marks here if that's okay. So I found out that this is 54 degrees. So this is 54 degrees. What's all the way around the circle? How many degrees? 360. So I took 360 minus the 54, and that gives you 306. Just another way you can get there. Very good with what you did. If that, they said if that looks like the diameter, you can go ahead and say that's the diameter. Did anybody look at it this way? No? Just trying to see where those vertical angles are at. I just want, not that you have to do it that way. I'm just trying to find you different ways for you to look at it. So when it comes time for ACT test, you can get to that answer quicker. Number 12. If you look at number 12, what did you get for an answer for number 12? 146. What they are asking you for is the measure of SPQ, and that's a good question. What is that measure going to be? So the question was SPQ. If you look at it, here's S, here's P, and here's Q. And I told you there's actually two angles that measure that. One's a reflex angle right here, and the other one is just going to be an obtuse angle. They're going to look for the smaller one, so they want this obtuse angle right there. So how did you go about trying to find that? Because it doesn't appear that you really have any diameter there, do you? So how do you go about finding it? I missed a measure. They do tell you this is 60 degrees right there, correct? Did some of you try finding each individual angle measure? No. What I would probably do is you find this one right here, find that major arc. What's that major arc? 214 degrees. And what's the major and the minor arc sum got to be? 360. So take 360 and minus 214. And if you do that, you end up with 146. So SPQ would be 146 degrees. Now, what if they happen to ask you what is, just by curiosity, what is the measure of angle SPT? Then what would you do? I would probably take 146, which is that full arc there. You see those two blue tick marks? It's saying those are equal angles. So 146 minus 86 is going to be what? $60. And then you're splitting it into two equal parts. So just the one angle would be, there goes my cap on, 30 degrees. So it's going to be 30 degrees. Okay, if we look at number 13. Number 13, what did you get for an answer? Very good. 234. Number 14 is asking you for the measure of the arc EFC. So here is E, here is F, and here is C. So you want to go EF over to C. How did you go about finding that? You found the 180 and you found this angle and then you added that angle to it. All the way around is what? 360. What do you know about these two right here? What's that going to be? 126, which means this arc C to E is 126. So how else could you find it without finding these individual angles right here and right here? Just take 360 and subtract 126, and that's going to give you the 234. Otherwise, you can do 180 minus 126, find this angle, find these two angles right here, and then add those three angles together. Does it work? 360 minus 126 gives you 234. Is that faster? I don't know. You tell me if that's faster or not, a way of looking at it. It may not be faster if you don't see it. You're going to sit there and you could have had your answer found instead of going, now what did Mrs. Schultz say about that one? I don't know. And then on number 14, what did you get for an answer? You should have had an answer of 125 degrees. Because what they want you to find is the measure of angle MIJ. So here's M, I is in the center, J is over here. They want this angle. What's this angle measure? That's 55 degrees. So take 180 minus 55 and you end up with the 125 degrees. Okay with that? All right, we get to number 15. Do you think 15 is something you could do? Yes. 15 looks something like this. And they tell you that this is 140 degrees right here, and this arc is 6x minus 8. And they ask you, solve for x, assume that lines that appear to be diameters are actual diameters. Definitely need to do that with my drawings, I'm sure. So if you look at it, you see where the 140 degrees is at. What's this angle measure right here going to be? 40 degrees, which means your arc also has to be 40 degrees. So 6x minus 8, 6x minus 8 has to equal your 40 degrees. So 6x is equal to 48. So x is equal to 8. Number 16. Number 16, they mark equal angles for you again. I tried copying this off in color, but somehow it did not come off in color if I remember correctly. So they give you something that looks like this, and these two arcs are marked with tick marks. That says that they're going to have equal values. This is x plus 93, and they want to know what is x. -3. Because if these are equal angles, this does look like a diameter, correct? Yes, so if those are equal angles, each angle is 90 degrees to give you the 180 that's in the diameter. So x plus 93 is going to have to equal 90 degrees. And if you subtract 93, you find out that x has a value of -3. All right, what I would like you to do is to do 17 and 18, please. Okay, so here's how some of you found it. Some of you looked at this right here, and this is 12x minus 2, right? So this is 12x minus 2. Is that the way you looked at it?
Yeah, then I said
6x minus 1. So then each one of these pieces has to be 6x minus 1, which is half of that. You could look at it that way. So then you said 5x minus 10 is equal to 6x minus 1. You could do that. Yes, you could do that. And then if you do that, because you take half of this, so take 12x minus 2 and you take half of that, which is going to be 6x minus 1. Okay, so you solve that and you get x is equal to, oh, sure that oh, that's a plus. I miscopied the problem, I'm sorry. There's a plus right there, which makes this a plus. Much better now. So then you get 11. So if that's the case, if you find out that x is equal to 11, what we are really looking for is this arc right there, which means we are looking for this angle measure in red. Did you put 11 into, where did you go? Maybe I should ask you that. Did you put 11 into 12x minus 2? Oh, you didn't do that yet? Okay, I would put 11 into 12x minus 2. Do you remember what happens when you take 11 times 12? You split it in half, and so I'm going to use 12 times 11 minus 2, and that's going to give you 132 minus 2, which means that this right here is 130 degrees, which means what is the other angle? 50 degrees, which means its arc measure is the same, which is 50 degrees. Do you see how you can find that now? Is there another way anybody else solve that? You could make the statement just like this, and if dividing 12x minus 2 by 2 is a problem, then you could still go with that concept and you could say, well, 12x minus 2 is the same thing as doubling 5x plus 10. And you could solve that problem. That's still going to get you to x is equal to 11. So you look at number 18. Haven't had a chance to work on it yet? Due to time, you just want me to go through? Yeah. So as we look at it, now hopefully I got all, nope, it's a good thing I looked. This is a plus 2, is that correct? Oh man, negative 2x, or negative 27x minus 3. All right, we know these two arcs are the same, or these two angles that are marked are the same. They want the measure of angle VST. Here's V, here's S, and here's T. So what they are looking for is this right here. I want to know, what is that angle measure? All right. How can I go about finding x? A suggestion? Remember, the green's what I'm looking for, that angle. But what do you know about those three arcs? What do you know about those three arcs? They equal 360.
But that one's equal to that one.
But that one's equal to that one. So that means that this green arc is what? Negative 27x minus 3. And I know that if I take negative 27x minus 3 and I add to it negative 27x minus 3 and I add to that, oh, I should have done that in a different color. Okay, this one right here is the purple arc. So I add to it negative 27x minus 3. And then I add the red arc, which is negative 37x plus 2. All of that has to equal how much? 360. Can you find out what x is? Okay, did anybody do that? What is it, Jacob? -4? I'm going with Jacob's answer there for a second. So 27 plus 27 plus 37, you add all that together. 2, 4, 6, 91. So I think you get something like -91x minus 4 is equal to 360. Is that what you got? I'm trying to do it in my head real quick. So then you get -91x is equal to 364, and you divide by 91, -91, yes, and you end up with -4. I agree with that. Now what they want though is they want this angle measure right here. They want angle VST. So if they want angle VST, you put -4 in, you can put it in right with that arc value. -27 times -4 minus 3. So if you take 27 times 4, you get 108, and then you subtract 3. So what is this angle measure equal to? 105 degrees. So you work with either the diameter, 180 degrees, you work with the circumference of a circle, 360 degrees, and use that to break it down and find other parts. Questions? All right, I hope that's recorded well enough for those that are gone.